All right, here we go. 5.3 talks about dividing polynomials. The first process of dividing we're going to talk about is using long division. Okay, so a couple quick examples. I suppose using long division, I'm dividing by, this is kind of like dividing by a monomial too, obviously. So I have this divided by 3mn. Now, when you're dividing by something or dividing by a monomial, this is actually pretty slick, and where all you have to do is take each individual term in your first polynomial and write it as a fraction with this monomial. So in a particular situation, you have this right here. So then I'm going to rewrite this as, this is somewhat time consuming, but like I said, you get used to this, and then a lot of this stuff can become mental algebra. So, but I would strongly suggest that you write it down until you got used to it, I guess. So each individual term I'm dividing by this monomial, which now all I do is simplify. So 12 divided by 3 is just 4. M divided by m, it actually cancels out, so because you subtract the exponents. Remember, when you're dividing, you subtract the exponents. N cubed divided by n, I'm just going to actually be left with n squared there. So this term simplifies to 4n squared plus 3. On top, I'm just left with m squared minus m is going to be m to the first. And then also, n squared minus n, or minus 1 here. You guys understand what I'm talking about here. N squared, and then n to the first. I get n. And then 15 divided by 3, I get 5. M, and then the n's cancel out there. So my final result there ends up being 4n squared plus 3mn minus 5m. Okay? That's somewhat long division by a monomial. Right? Well, let's say we weren't dividing by a monomial, we're dividing by say a binomial. So my first goal is to rewrite it as normal division problem. Now, another thing it's kind of key to note is, notice that I'm not missing any terms in here. Like, everything is in descending order. Now, if I was missing a term in here, I'd have to actually put a place filler in there. So, for example, if I didn't have any n squareds, I'd put a 0 n squared right here. That's called a place filler. So my process would work out. Everything would line up properly. Does that make sense? So you need to pay attention to that when you do a long division. You need place fillers. Okay? Now, the first thing that we do here when we do long division is we compare the first terms in the divisor and then the dividend here. So, for example, I go off to the side somewhere and I say, well, n cubed, I compare that, I simplify it, I end up getting n squared. Okay? What that becomes my multiplier up top here. So, so I compare the first terms over here. I get n cubed divided by n equals n squared. That becomes my multiplier on top. Now I take that value and I distribute it through here. Okay, so I take n squared times n, I get n cubed. N squared times 4, I get 4n squared. And then I go ahead and subtract. Okay, subtracting 2n squared minus a 4n squared, where I get negative 2n squared. N cubed minus n cubed is 0. Now I go ahead, just like I do normally, I bring down the next value. And I repeat the process all over again. Okay? So now I take the first term in my dividend here.
Good morning. We have a couple announcements.
And now they have announcements, which is very annoying.
Council will be providing a soup luncheon on December 15th.
So let's
Julia
follow
will
along.
be sending an email out to the high school staff. Please RSVP if you would
Everybody
like
agree with that?
It will be serving soup, salad,
Simplified,
garlic
right?
bread, and
That
chicken.
becomes my next
Tickets
multiplier.
are $5. The money will be collected on Thursday and Friday during
Negative
lunch.
2n distributed
All
through
proceeds
here.
go to the National Honor Society's Relay for Life.
I get, what do I get? Negative 2n squared.
Don't forget to bring in your
Minus
soft balls and
8n.
canned food. And
Subtract.
congratulations to both the basketball and wrestling
Negative
teams.
5n minus a negative
Have a good day.
8n actually becomes a plus 3n. This cancels out because a negative 2n squared plus a minus 2n squared is going to be canceling out. So that helps out a lot. Bring down the 12. Start over again. Compare my first terms right here. So what do I get? 3n divided by n, I get 3. Because my n's cancel out. Everybody agree with that?
Yeah.
Okay? So I get plus 3. Distribute the 3 through. You get 3n plus 12. And I subtract. Look at that. Do I have a remainder?
Nope.
No. Sweet. So n plus 4 divided by n of this polynomial right here is actually equal to that. Long division. Thank you very much. Awesome. Thank you. 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 Well, you know, we also can do that using what we call synthetic division, which is pretty cool. I'm going to do the same exact problem using synthetic division. Okay, let's do that.
I have
Huh?
a question.
What? Uh-oh. Question.
What would you
We have a question.
do if you had a remainder?
Okay, good question. We did have a remainder. For example, let's just say hypothetically that this came out to be what? Say this was 10, and we subtracted, and I got a remainder of 2 right here. What do we always do with the remainder on a normal problem?
We compare R than 2.
R than 2 sometimes, or we usually make a fraction with the divisor. Okay? This is the numerator and this is the denominator. So what we would have here would be plus 2 over n plus 4. Remember that? If we do that with in numbers, so for example, let's say that I had 23 divided by 5. Well, I had to put what? I get 4, 20, and I get a remainder of 3. Well, it'd be 4 and 3/5. I take the remainder and I put it over the denominator, right? So I get 4 and 3/5.
Okay.
That's exactly what I do here. I get whatever the remainder is, whatever the remainder turns out to be, I put the remainder over the divisor and I add it to there. Plus here, plus. Make sense?
Yep.
Good question. Alright, going to do the exact same thing. Hopefully we get the exact same answer using what we call synthetic division rather than long division. No. Yes. Oh, yes. Oh, yes, no. Yes, no. Let's see here. What do we do? Think. Oh, okay. So what we need to do when we do synthetic division is the divisor is n plus 4. So actually what I need to do on that is I need to figure out what, what makes this expression 0. What value for this expression makes it 0? So off to the side somewhere I'd be like n plus 4 equals 0. What makes n 0 there?
-4.
Negative 4. Okay, n equals -4 would make it 0. Okay, so that value is going to go in this little box right here. And then I'm going to draw a little line right there. And what I'm going to do is I'm going to use, this is called synthetic division. Now I'm going to take the leading coefficients of each term and what do I call this? The dividend. I'm dividing into this term right here, right? This polynomial. I want the coefficient of each one of those terms. What's the coefficient here? 1. What's the coefficient here? 2. What's the coefficient here?
-5.
-5. Coefficient here? 12. Okay? Okay, so the coefficients here, and then here's my divisor right here, -4. Okay, this is called synthetic division. Okay, it's kind of a quicker method, really. Okay. Now another thing to point out is what happens if I were to not have one of these terms. Notice that this polynomial is pretty good because it's all in descending order. There's not a missing term involved here. If there was a missing term involved up here, what would I have to put down here? A zero, a place filler, and then use a 0. Exactly. And now, I'm going to start this off. The process of starting synthetic division off is you bring the first digit down here, you just bring it down. Okay? And then you multiply. -4 times 1 is -4. And then you start adding your columns. So -4 and 2 is what? -2. Now you multiply again. Actually, it's +8. And then you add 3. You multiply again. You get -12. 0. This right here, the last column, last thing, should actually, whatever results here, you should, our previous result, we had a no remainder, right? That's actually what happened here is we had no remainder. Okay? So this results in no remainder. Okay? Now, if you do have a result here, that would be a remainder. That makes sense? But we didn't. So now, what do these values here stand for? These are the coefficients of the degree, 1 degree less of what you started with. So we have degree 3 here, right? So this actually means 1n squared. This is the coefficient of your next term down, which is actually -2n plus 3. Notice that? And then the exact same answer we got before, wasn't it?